Hi everyone, my name is Elnaz Khorasanian. Today we want to talk about molecular docking. Molecular docking means predicting the interaction between protein and ligand, whether or not they can interact with each other, and if so, in what state they can have the most interactions and the least possible energy loss. Our project about molecular docking of cortisol on glucocorticoid receptor and include 4 steps. The first, download and prepare ligand. 2. Download and prepare receptor structure, perform molecular docking, and finally review and compare results. To prepare the ligand, we use PubChem site. In this site, type ligand's name and usually the first result is the most relevant. As you can see, the first is best match. The first is best match. We do it from the 3D Conformer download 3D structure in SDF file extension. 2 sites can be used to access the receptor. In this way, we first search the name of cortisol on the UniProt site. In the results section, find the sequence and copy the sequence from FASTA section. In PDB site, we use advanced search, and in sequence search, paste the copied sequence in this section. This site offers some examples of receptor and structure. There are several important factors to consider when choosing from them. The first is about date of release. The newer the structure, the better. From the method part, we can make the amount of structure of resolution. The smaller the number written in angstrom, the better the structure of the resolution. We use the UCSF Chimera software to do docking. Download in PDB format, receptor structure. Okay. For perform molecular docking, we use UCSF Chimera software. To start, we call the download receptor and ligand file from File menu and the Open option. File menu and Open option. To remove extra molecules, that is the molecules that come with our main protein in the download structure, from select menu, residue option, and then from action menu, select atom and bonds and delete option. Action menu, atom and bonds, and delete option. To prepare for docking, changes must be made, including the addition of water molecules and the completion of imperfect chains in our structure. In these changes, the net load of charged amino acid must be added and add polar hydrogens. From tool menu, structure editing, by opening the box and clicking OK, we can save the edited file in these sections. Add hydrogens, add charge, and click OK. The next step is to minimize, which is a longer task, and our goal is to lower the energy level of the structure. From the tool menu, structure editing, and minimize structure. Finally, to start docking, open both the ligand file and the minimized receptor. From File menu, select Open option and choose both the files. The next step is to determine the active site amino acids, that is the amino acids in the structure that bind to our ligand. We must show active site amino acids. For do this, from PDB site in the interaction part of receptor and ligand, we can find active site amino acids and number of their places. After that, from favorite menu, sequences, all active sites must be specified in the open box. By selecting from the list, amino acids will be highlighted. The next step, present menu, interactive 1. Change the color of amino acids to identify selected amino acids at the active site. To start docking, from Tool menu, Surface Binding, Analyze, and Autodock Vina. Chimera software along with Autodock software can do docking that must be pre-installed. In this box, we make the pre-docking setting. Select the receptor and ligand file. In the next part, in the center, we put 0 for all and put 10 for all size. Center and size. You can enter the exact coordinates of the active site in the center boxes, and you can manually move this cube to the location of the amino acids of the active site and place it. We have to position the cube so that it contains all the active site's amino acids. The cube coordinates box is activated automatically. All options must be true, and finally select the location where we want the file to be saved. And finally, docking results. After docking is completed, a table appears that specifies the number of docking modes. That is the number of modes whose ligand can be connected to our structure and placed side by side. Now we have to choose the best of these modes, that is which one is more likely than the others. Selecting the H-bound options determines the number of hydrogen bonds which the ligand is attached to the structure. Of course, the greater the number of hydrogen bonds, the more stable the bond. After selecting the complex has less energy, save this with new name. This section. And save with new name. Two sites can be used to analyze the result. I use PLIP site. From the choose file and select the complex and select the analyze. In this site, choose file, analyze. The number of hydrogen and hydrophobic bonds can be checked. We can compare the result of analyses. For compare, we can For compare, we can download the cortisone ligand from PubChem and we do the docking steps on the receptor structure as before. After docking and selecting appropriate mode, using the PLIP site, we check this results in. This comparison includes the number of hydrogen bonds and the energy of the bonds and their lengths. Hydrophobic interaction, hydrogen bonds. Thank you for your attention.